you must have with you also, each of the modules. And the sixth session will be devoted for last minute discussions, revisions, or doubt clearing session. So that is there. All right. So one thing that you must keep in mind is that as we go through these sessions, individual sessions, you may have lots of questions in your mind. You may have certain doubts. So please make note of those doubts and make note of those doubts and try to ask them at the end of the session. What I will do is I will try to finish the sessions a little early, let's say in 10 minutes time or something, or 10 minutes before the scheduled time, something like that, so that we get some time to discuss the questions that you may or doubts that you may have. But even if we do not get that time in individual sessions, do not worry. Make note of those questions or queries that you have. In the sixth session, as I just mentioned, we will have a discussion, doubt clearing session, and last minute revision. So you don't have to worry about that. All right. So one request, please do not put queries into the chat box during the session. If you have any doubt, please make a note on your notebook. Keep it with yourself. At the end of the session, please put it in the chat box or in the Q&A box, and we'll try to, answer those questions for you. And again, a reminder, if those questions are not answered in any individual session, please um, uh, wait for the sixth session, because sixth session is exclusively devoted for doubt clearing and last minute revision. One thing. Second thing, before we start, there can be many questions like what kind of questions are coming for the examination, how do I complete my assignments, how do I plot graphs in the online examinations, and whether the videos will be uploaded and all that. These are all administrative questions. Please ask the administrators and they will be able to give you a complete and better answer. My job here is to discuss the course modules with you, solve your queries, and if these queries do not get solved in individual sessions, you will have a sixth session exclusively for that. And even in the middle of that, if you still have any questions, you can always log into your Amity Online account and send me an email through that. I will try to answer those questions even through emails. All right. So a request, don't put any questions in the chat box or a Q&A box in the session. Wait for the session to end. I'll try to finish off a bit early. We'll discuss it then. Or if not in that, in the sixth session, and even if not there, then you can always send me an email through your Amity login, and I'll try to answer your queries there. All right. For all other questions, please ask the administrators. They will be in a better position to answer those questions. All right. Having said that, these modules are quite large. In a sense, a lot of topics are being covered in the same in individual modules. That is why I need to be fast in covering the syllabus, if at all we want to cover it. So bear with me, and that is why you will have questions. Please make a note of those questions and ask them when the time comes up. All right. So for this beginning session, by the end of this session, we hope that you'll be able to understand how business uses statistics, learn the types of data and the measurement scales in this, what are the measures of central tendency and variations in the data, and how to use Microsoft Excel to calculate data summaries. If the time permits, we'll also look into that, because after doing your master's, you'll be going straight into a job, and or you already may have been employed in a job. So learning Excel for doing these managerial problems is also an essential skill. We'll try to focus on that also. All right. So what is the use of statistics in business? Basically, it summarizes the data that you have. So descriptive methods to create charts and tables gives you a quick summary of what does the data look like. We also make use of statistics to draw conclusions from the data. So inferential methods are used, which we'll be studying a little later. Hypothesis testing and forecasting are the inferences. And then based on that, you can make predictions or draw conclusions about your, let's say, group of customers or your vendors or the market scenario in general. And of course, based on that, you can be able to make forecasts about your business activities, your inventory levels, your reorder levels, what will be the price that the particular product will command in the market, what is going to be the potential size of the market, like these kind of things. You can make prediction based on that. And of course, if you learn it properly, then you can also control your business operations, make it more flawless, and we increase up to what we call Six Sigma levels. We'll look into what Six Sigma is a little later as a level. So this is the importance of business statistics in management. So statistics as this level is generally divided into two major ways, approaches. One is called descriptive statistics, where the focus is only on collecting, summarizing, and presenting data and analysis of data also. Inferential statistics is basically analyzed in descriptive statistics. So inferential statistics is a separate branch, is more complicated, of course, because more advanced, not complicated, more advanced, because you're learning a lot of different techniques to actually draw meaningful conclusions from your data and then make good forecasts. All big business decisions are based on good forecasts. Please remember that. So we'll start with inferential statistics and then move on to descriptive statistics. As for the connection, my connection is optical file LAN wire connection. Probably, if you get any network issues, please check with your connections also. Plus, it is raining very, very heavily in the area that I live in right now. So there may be some issues, but not very sure. If at all there's an issue, I will switch off my videos. As of now, I don't think there's an issue with the connection. All right. So what is the process? The process is to collect data, probably through a survey. You can also have secondary data, that is the data is already collected, but you can extract the meaningful data or relevant data that is for your use. Then present this data into tables and graphs for the business decision makers to make conclusions and make their decision based on that. And then characterize that data, find it the sample mean, median, how the data looks like, something like that. All right. So inferential statistics is basically based on this one major area that we must understand clearly. And that area is this basically this, that just give me a second. Sorry. That the idea is basically this, that we make use of estimation techniques. What is estimation here is this, that we make use of a small group of people, which we call sample technically, to draw conclusions about a larger group of people, which we call population. So, for example, if we are trying to estimate the market size for a new product that I'm going to launch in, let's say, Mumbai. So, what happens in this? The If the product happens to be, let's say, a breakfast cereal, meant for grown-up people, so those who are working people. So all those who are 18 years and above, presumably 18 to, let's say, 60 years of a working age population, male and female both, they become my target customers. So all of those who belong to this age group and are working become my target customer. But will all of them buy? That's a separate question. But they are my target customers. So in Mumbai, that population suppose happens to be about 7 to 8 crores 8 crore people. So sorry, no, 7 to 80 lakh, 70 to 80 lakh people. My mistake. In Mumbai, that happens to be 70 to 80 lakh. Let's say 80 lakh people fall into that category. They are my target customers, and I want to understand whether this particular breakfast cereal will be taken up by them. Will they actually make use of it? Will they prefer the taste and the flavors that we have put in, or the ingredients that we have put in, or do they accept the product at that particular price point or not? So there are many ways of finding out that. One simple way is actually conducting a survey. So you cannot contact, ideally, you should have contacted every single 80, each of those 80 lakh people who are your target customer, ask them certain questions, get their point of view, and then draw your conclusions. But is it practical for anyone to contact all of 80 lakh target customers? No. There are many problems with that. Number one is time. Do you really have time to contact all 80 lakh people? Probably no. Number two, do you really want to spend money and resources in contacting those 80 lakh people? Because you cannot individually go to contact those 80 lakh people. You'll have to hire people. And those hiring those people will cost money in terms of not only paying them, but also training them how to ask questions, how to reach those people and all that. So time could be one problem. Resources could be another problem. That is why what we do in this cases is we talk to a small group of people from among those target 80 lakh people. We call that sample. So that 80 lakh, your target customer base is the population in statistics. And the smaller group from within your target population, target customer group that you have taken to talk to is the sample. So we take out a sample of, let's say, 10,000 people. Instead of talking to 80 lakh people, we only talk to 10,000 people. This is much, much smaller sample, manageable, although this is still a large sample, manageable. And you ask questions, you try to draw conclusions from the answers that they give, and then you try to draw conclusions for the larger or in 80 lakh target customers. The question legitimately to ask is, how can a small group of 10,000 people give you a true representation of the larger 80 lakh people? And this is where the beauty of statistics lies. The answer lies in drawing the sample. If the procedure for drawing the sample is accurate, that means if we are doing the sampling in such a way that the smaller section group of people that we selected are representative of the entire population, then what happens? The conclusions that we draw from the smaller group of people, our sample, can be easily or accurately attributed to the larger set of people, which is your, which is your population, the target customer base. All right. So this is what we do in statistics. We estimate about population based on the results we get from a representative sample. And then we have got something called hypothesis testing. So for example, we want to estimate the population average weight. Then what we do, we draw a sample of people, take out the average weight of those sample of people, and then based on that, we do a hypothesis testing, which will explain how the, which will give you whether the population mean weight is around what we had postulated earlier from the sample. We'll take these through examples. This is only an overview. We'll take these things through example. Don't worry with that. All right. So essentially what we're trying to do is drawing conclusions about a larger group of individuals based on a smaller group of people. This is what in general is the science and art of statistics. There are certain concepts, certain keywords that you must keep in mind. One of them is variables. Variables are basically characteristics of individuals or items or objects that we want to analyze using any statistical method. It could be income, it could be expenditure, it could be weight, it could be height, it could be taste, it could be preferences, it could be age, it could be anything. So data is basically the actual value which is associated with a variable. For example, I'm interested in knowing the average expenditure on food items of a particular locality. All right. So what I do is money is spent on food items from monthly budget becomes your question. So how much money do you spend on purchasing food items, not cooked food, food items on an average in a month? So for household one, it will be a figure. For household two, it will be some other figure. For household three, it will be another third figure, so on and so forth. So these actual values that they say, for example, we spend 20,000 rupees on purchasing food items that we cook at home. And the third house will say we spend only 5,000 rupees. The first house would have said we spend 10,000 rupees. So these 10,000, 15,000, 5,000, 20,000, these are the individual values, data points, which are associated with the variable expenditure on food items. All right. But at the same time, it may seem to you that it is a very commonsensical definition that food item is a very commonsensical understanding what is food item. But in real research, in such analysis, we must operationalize our definition. That is, food items has to be defined properly. What is understood by food item? Does ordering from Zomato also constitute a food item? Or dining out at a restaurant also constitutes expenditure of food item? You have to define that. All right. So be careful about what we are defining, operationalizing our definitions. Then we identify the variables we are interested in, depending on the problem we are looking at. And then we collect the data values for those variables that we are interested in analyzing through this statistical analysis. All right. This is what we must do. All right, population, another key term which we have just encountered is basically all the individuals that you want to draw conclusion about. This is your target customer base. It could be vendor base, it could be customer base, it could be policy objectives, it could be anything. All right. So customers could be defined as students in a university. They can be defined as diners at a restaurant. It could be defined as purchasers at different vendor markets. They can be defined as in numerous ways. So what is your specific problem? Based on that, you define your target population. Target population can be your customer base also. All right. So once you define your target population clearly, this is how you operationalize the definition of population in your particular problem. The sample is basically a small set of people drawn from your target population. And the small set of people, the sample has to be representative. Suppose, for example, you're trying to understand the smoking habits of college-going children. All right. So what has happened is that in Western countries, where this smoking has come from, the dangers of smoking, but smoking as a lifestyle has gone up in developing countries like in India. So what has happened is that we try to understand what is the smoking habits of college-going students in a particular city, let's say Mumbai. So what happens if you go and randomly talk to students in a college? You may end up interviewing most of those students who do not like smoking, or you may end up interviewing most of those students who like smoking. The point is this: if you do a random sampling in this way, what happens is that you are ignoring the fact that in your population, that is college going students, there are both smokers and non-smokers, and they are in different proportions. You don't know about them. So if you do a random selection, you may end up talking to all those or majority of those who don't like smoking, or you may end up talking to all those or majority of those who like smoking. In both cases, your inferences about college-going students' attitude towards smoking would be misguided. So the key is to realize that your population in this case is not homogeneous. College-going students is not a homogeneous group. It's not a group which is exactly the same from to each other. So there are people who like smoking, there are people who do not like smoking, there are people who are occasional smokers, there are people who are chain smokers. So you have to understand that your population is not exactly the same. One individual is completely different from another in many respects. So what we say, different classes or strata, that's a technical word, exist in your population. So doing a simple random sampling that is going to certain universities, standing outside the universities as the classes break out or the colleges all go off, you go and talk to, or you approach random people, and those who agree to talk to you simply collect their data. This random sampling will not work over here. So you have to do a planned sampling in such a way that the number of smokers, non-smokers, heavy smokers, light smokers, occasional smokers, uh, all of these are part of your sample in the same proportion in which they exist in population. How do we do that? Is a separate topic we'll be studying later on, but this is how we decide upon a target, a representative sample. So the trick is, if you get a true representative sample, then the statistical analysis based on the sample will give you a more or less accurate understanding of what the population is like. All right. So when we are talking about any attribute of population, we use the word parameter. When we are talking about any attribute of the sample, we make use of the term statistic. Parameter and statistics are basically the same. The difference is, when we are talking in terms of population, we use the term parameter. When we are talking in terms of the sample, we use the term statistic. All right. So data is the core of this entire discussion. So these variables, this data are of basically types: categorical and numerical. So categorical variables, as the name suggests, they are non-numerical variables. That means these are the variables which basically look at the properties or attributes or characteristics of the target population. So the answer to your survey questions or the questions that you ask will lie into different categories. For example, what is your marital status? It could be married, unmarried, divorced, widowed. So these are all categories. So which political party do you support? Your answer could be anything. These are again categories. What is the color of your eye? This again is a category. So we'll look into the individual example. So any question that gives you answer in terms of noun or pronoun is categorical. All right. And in contrast to that are got categorical variables are also called qualitative variables because they try to measure the quality of the individuals that we are talking about. In contrast to this, we have got numerical variables. Numerical variables, as the name suggests, goes in terms of numbers, that they are measured in terms of numbers. So what happens is this numerical variables are also sub-classified into discrete and continuous variables. So discrete variables are variables which can take any value, which cannot take any value in a given range. They can only take specific values. For example, the number of students who have joined this online session. This can be 1,500, 1,600, 900, 1,000, 1,000. The number cannot be 957.25. You cannot have 0.25 student joining this particular class. Number of blades in a fan. It can be 1, it can be 2, it can be 3, it can be 5. It can never be 3.73. You cannot have a fan which has 3.73 blades. 0.73 blades do not exist. There's no meaning to it. All right. So discrete numerical values are numerical values which are only allowed to take certain values in certain ranges. All right. In contrast to them, continuous numerical values are the variables which can take any value within a range. For example, weight, voltage going through an electrical circuit, your age. Suppose you have turned 17 on the 1st of January 2025. Now, on the 1st of January 2026, you will be 18. Does that mean that your age is frozen for an entire year? You sleep as 17-year-old on 31st December 2025, and when you wake up on 1st January 2026, you are suddenly 18 years old? No, it does not happen that way. Your age increases every single moment that you're alive. So the value that age can take is basically anything between 0, that means you're not born, to the natural age to which humans live. So this is a continuous numerical variable. Income, expenditure, these are all examples of continuous numerical variable because they can take any values. Specifically, they can take values in decimals. Also, we'll look at this. So these variables are measured on different scales. So the categorical variables are, to begin with, are measured on something called nominal scale. A nominal scale is the scale in which data is classified into distinct categories. For example, do you own a personal computer or a laptop? Answer could be yes, no. So I'm putting a person into a category of ownership by answering yes, putting another person into a category of not non-ownership based on his answer of no. So what kind of stocks do you own? So they are growth stocks, they are value stocks, they are thematic stocks. There are different ways of this. So what am I doing? I'm classifying an investor based on the types of stocks he or she owns. So which is the internet service provider that you use? It could be Microsoft Network, it could be America Online, it could be anybody else. Nowadays in India, we have got only Jio, Reliance, and Airtel looking into this. Looking at this. So the answers to these questions are basically putting them into different categories. The answer result in what we call in English as noun or a pronoun. One thing that we must keep in here, mustn't stand over here, is this. There can be instances when the answer to the question would look like a number, but they may not behave like a number. For example, if somebody, if a teacher walks into a classroom, and my name is Animesh Karn, and I have a roll number 35. So a teacher walks into the classroom and she takes attendance and she calls out my name, Animesh Karn. I reply, present ma'am. But she could have done something else. She could have walked into the classroom, taking attendance. She could have called out my roll number. So roll number 35, I would again answer present. So what has happened over here? 35 is a number. Animesh Karn is a non-numerical thing. All right. It's a name. So whether the teacher calls out the name, alphabet, Animesh Karn, or the teacher calls out the number 35, in both cases, I respond. Why is this so? Because 35, although looking like a number, is actually a proxy for me. It is a substitute for me. It is something called a pronoun. In English, noun and pronoun. So my name can be Animesh Karn, my pronoun would be I. Your name could be, let's say, Mahesh, your pronoun would be you. So Mahesh come here, you come here. Same thing. So Animesh Karn, roll number 35, same thing. So roll number 35, although looks like 35 as a number, does not behave like a number over here. One more thing will make it clear. Suppose somebody walks into your classroom and says, what is the average roll number of your classroom? Does this question even make sense? It makes no sense. One more example. You all have got mobile phones. So there is a 10-digit number of your mobile phone. What is that number? Is that a numerical thing? No. A number is basically, again, like a roll number, a representative of you. So somebody wants to give a call to Animesh, and what does that person do? That person can open up his phone and go into phone book, look at my name, click on it, the call will go to me. Or if that person does not know my name, has got only a number, the person will dial that number, the call will again come to me. So my phone number is basically my representative. It's a pronoun for me. So you're calling Animesh Khan or you're calling his phone number. Same thing happens. Again, this phone number acts like the roll number in the classroom. For example, if a family, mother, father, son, daughter, all four of them have got different phone numbers, mobile numbers with them, and somebody walks into your house and asks, what is the average mobile number of your house? Will that question make any sense? No, not at all. So be careful. These may look like numbers, but they do not behave like numbers. They are again measured on a nominal scale. They are categorical data. They put something into categories. So any question to answer to which is noun or pronoun in the English language, by definition of English language, that can be said to be measured as a categorical variable or on a nominal scale. So categorical variables can also be measured on ordinal scale. What does ordinal scale mean? Categorical variables, as we understood, are categories, all right? But if the categories are ranked, there's an order in which, or a preference in which these categories are put, then we can say that they are measured on an ordinal scale. For example, if you walk into a restaurant, have a dinner over there, and you ask for a bill at the end of the, you ask for a bill. So the waiter comes to you on your table and gives you a piece of paper, which is basically a feedback paper, in which one of the questions is, how satisfied are you with the lunch or dinner that the quality of food that was served to you? So how satisfied are you with the quality of food that was served to you? The responses would be, possible responses would be extremely satisfied, somewhat satisfied, neutral, somewhat dissatisfied, extremely dissatisfied. So these can be five possible answers to the question about the quality of food. Now, these are all categories. If somebody, responds that I am extremely satisfied, that person is put into the category of highly satisfied customers. If somebody responds that I am extremely dissatisfied, that person is put into the category of extremely dissatisfied customers. So what happens is this, that just give me a second. Sorry, there's a problem. Just give me a second. Sorry. All right. So we are talking about ordinal scale. So what happens is this: if somebody, as I was saying, that if you walk into a restaurant, have a dinner, and at the end of it, the waiter serves you a paper in which the question is, how satisfied are you with the quality of the food that you just that was served to you? And the responses are extremely satisfied, somewhat satisfied, not satisfied, extremely dissatisfied. So if I respond to extremely satisfied, the owner will put me into a category of extremely satisfied customers. If I respond as neutral, it will put me into a category which is undecided. If I respond as extremely dissatisfied, then the owner will put me into a category of customers who are very dissatisfied with the quality of food. So these are all categories which I put myself in depending on the answer that I make. But then there is a hierarchy. On the scale of satisfaction, somebody who has ticked extremely satisfied is at the top. Somebody who has ticked extremely dissatisfied is at the bottom. So there's a hierarchy going on. So there's an order. All right. Suppose somebody asks you among the three flavors of ice cream, let's say strawberry, vanilla, and chocolate, which one of the you order them in the order of your rank them in the order of your preference. So there are three flavors given to you: strawberry, vanilla, chocolate, and the person has asked you to rank them in the order of your preference. So most preferred to the least preferred. So you rank, let's say, vanilla, then chocolate, and then strawberry. So what happens is this. Um, what happens is that this is again a category in which you have expressed ranking. The most preferred one is vanilla. Uh, the next one is chocolate, and the last one is strawberry. So these are rankings. All right, rankings of the preferences that you express. So anything like this is called a measurement on ordinal scale. The grades that you get in your examination, letter grades that you A plus, A minus, B plus, B minus, C, D, F. These letter grades are again ranking. So somebody who has got A plus is ranked higher, has got more marks than somebody has got B plus. Is ranked lower. So these are all ordinal scale because they are not numbers, but they represent a hierarchy. One more thing that must be clear over here. In ordinal scale, you may find that there are numbers again, but they do not represent, they do not behave like numbers. They simply represent rankings. So how does it happen? It happens in this way that in an examination, after the examination results are out, there would be students who have, there would be a student who has stood first, there would be another student who has stood second, there would be a third student who would have stood third, so on and so forth. So these first, second, third, they may look like numbers, are actually ranks. So this is an ordinal scale. We must keep that in mind. Then we have got two more scales, but these are numerical scales now: the interval scale and a ratio scale. The interval scale and ratio scale they do look like the normal numbers that we actually encounter in our daily lives, but there's a difference between them, which we must understand. It's a quite important difference. In interval scale, true zero does not exist. In ratio scale, true zero exists. Now, what is this true zero? Let's understand that. By saying that true zero exists, we mean that if on measurement something comes out to be zero, that means that particular thing is absent, is not present. And by saying that true zero does not exist, we mean to say is that on measurement, we choose as a researcher arbitrarily what is the starting point. Let me give you an example for better understanding of this. If you recall your high school science, you'll remember that the temperature at which pure water converts into ice becomes ice. If it is measured on a Celsius scale, it comes out to be 0 degrees Celsius. And the temperature at which pure water converts into ice, if that temperature is measured on a Fahrenheit scale, the value comes to 32 degree Fahrenheit. Let's take another temperature scale. This time it's Kelvin. So the temperature at which pure water becomes ice, if you measure that temperature on a Kelvin scale, the value will be 273.15. So what has happened here? We are measuring the same temperature, the temperature at which pure ice becomes ice. But there are three people, and three of them are using three different scales. One is using a Celsius scale, the reading is 0 degree. The other one is using a Fahrenheit scale, the reading is 32 degree. The third one is using Kelvin scale, the reading is 273.15. So the reading of the first person, 0 degree, is not absolute. If you change the scale, the value changes from 0 to 32 or to 273. So by changing the unit of measurement, the value changes. That means when we had 0 in the observation, that 0 was not true 0. That 0 came out because you decided to design your scale in such a way where the 0 would be measured as the temperature at which uh, pure water becomes ice. All right. Same temperature being measured at different scales gives you different values. There is no true 0. So I, for example, say I'm an astronomer. I'm interested in looking at the temperatures in the core of stars. And those are extremely, extremely huge temperatures. The Celsius scale or the Kelvin scale or the Fahrenheit scale will have no use to me. Since they are extremely large temperatures, high temperatures, sorry, what do I decide? I find that the existing temperature scales in the world are of no use to me. I'm talking about core temperatures of the stars, for example, sun. So I devise a new scale. I name it Karn. So I define the temperature at which iron melts as 0 degree Kelvin. I can do that. All right. So once I do this, this is my scale. I'm measuring temperature on an interval scale where the 0 is defined by me. And what is 0 for me? 0 for me is the temperature at which iron melts. All right. So this is interval scale. In contrast, if you look at ratio scale, if you get a value of 0, it means the thing that you're measuring does not exist. The thing that you're measuring does not exist. So even if you change the unit of measurement, the value 0 will not change. I'll give an example. My weight is 85 kilograms. On Earth, I am 85 kilograms heavy. Now, what is weight? Weight is basically the force with which gravity pulls you towards the Earth. So if you recall, go back again to your high school science, you'll find that if you go into space, since there is no gravity, you're weightless. There's no weight. So an 85 kilogram heavy man, Animesh Karn, goes into space and then takes his weight there, right? 0 kilogram. The meter reads 0 kilogram because in space there is no gravity, there is no pull. My weight is 0. Then I change the scale. Okay, probably it's reading 0 in kilograms. Let me take my weight in pounds. So when I take a pound scale and then again measure myself, my weight is still 0. There's no gravity, no pull, no weight. If I change the scale to tons, I'm trying to measure my weight in tons. Will there be a reading? No, the reading will still be 0. So no matter which unit of measurement I take, my weight in space will always be 0 because 0 means absence of something. I am weightless. You know that by your physics, high school physics, that in space, there's no gravity. Every object is weightless. So when I say, let's take another example. When I say my income last week was 0 rupees, what does that mean? It means absence of income. I had no income. So what happens if I change the unit of payment? Instead of saying in terms of rupees, I say my income last week in terms of dollars. So what will be the value? $0, since I had no income. Since I had no income, whether 0, whether you express it in my income in terms of rupees, euros, dollars, yen, whatever currency you think of, the value will always be 0 because I had no income. So this is ratio scale. This is what we mean by true 0 being present. True 0 means absence of something. So the difference between an interval scale and ratio scale, both are numerical data, is this, that on interval scale, 0 or the starting point is decided arbitrarily, but on ratio scale, 0 or starting point is not arbitrary. 0 means absence of something. So these are 4 scales of measurement we must be very, very careful about. Why? Because later on, when you find that what kind of statistics can you calculate using your data, what kind of statistical tests can you perform using your data, what inferences can you draw from your data, it all depends upon the scale of measurement. All right. So this is an example for of the interval and ratio data. Temperatures in degrees is interval data, interval scale. standardized examination scores, SAT scores, there are interval scales, height, weight, age, salary. These are all ratio scaling. All right. Now let's try to find out where you have collected raw data. How do we organize raw data, and the ways in which we can organize raw data. So as I extremely sorry for this. I just mentioned the way you can organize your data or construct charts or perform statistical tests. It all depends upon what nature of data do you have. This is absolutely important. So for categorical data, we can tally data into tables, and we can create something called a one categorical variable summary table or a two categorical variables contingency table. We'll look at both of the examples here. Suppose there's a survey of 1,000 banking customers, and you are asking them what is the preferred channel of banking that they like, they most prefer. So the options are through ATM, live telephone or automatic banking, drive-through service at a branch, in-person service at a branch, or using the. So these are the different channels through which you can avail of banking services. So you conducted a survey of 1,000 banking customers, and these are the answers. And you present this data into a table. So what is the variable over here? Banking preference is the variable over here, and associated with this is the value that you have calculated, that you have gathered, and that you present in the second column. So this is a summary table, right? One variable summary table. There is only one variable you're talking about, which is banking preference. It has got 5 responses, 5 different responses, and then we are presenting again, along with the number of or the percentage of people who had responded to a particular being their favorite banking channel. Looking at this data, you can see that banking in person at branch is the most preferred way of doing banking. 41% of all the banking customers that you have surveyed, this is 1,000, have said that they prefer doing banking through in person at branches. So 410 people. This is a summary table, only one variable and the values associated with that particular variable. All right. When in most of the cases, we can have more than one variable. And in that case, we construct something called a cross tabulation. We'll take an example. Suppose that you are auditing a particular company's finances. So you draw a random sample of 400 invoices because it's a large company and there are a lot of invoices, and you're doing a quick survey, quick survey of how the company is functioning. So you draw a random sample of 400 invoices, all right? And then you categorize each of the invoices in 2 different ways. One categorization is the amount of money mentioned on those invoices. So if they are either small amount invoices, medium amount invoices, large amount invoices. And the second category is whether the invoices have any technical error in them. So there are invoices which have got no errors, one category, invoices which have got errors, another category. So then you count those numbers and present that into a table, the table that you have got in front of you. This is called a cross tabulation or contingency table. So what does this contingency table represent? It represents, number one, the total number of invoices drawn was 400. Out of these 400, 190 invoices were of small size, 140 invoices were carried a medium amount, and 70 invoices carried large amounts. That's one. Another way of looking at this is, out of these 400 invoices, 335 invoices had no errors, and only 65 invoices had errors. Now you can go more granular at the at the individual level. Now you can say that out of these 400 invoices that were drawn at random, 170 small amount invoices had no errors, 40 medium amount invoices had errors, and 65 large amount invoices had no errors, something like that. So this table has got 2 variables: presence of errors, yes and no, and the amount mentioned on those invoices. There are 2 different variables of the same thing, 2 different characteristics of the same thing, an invoice that we're looking at. We are looking at the same invoice from two perspectives. One perspective is, one quality is, one characteristic is the amount of money mentioned in them. So whether it's a small amount invoice, medium amount invoice, large amount invoice. Another characteristic is whether the invoice contains errors or it does not have any error. So when you're presenting two different variables, two different attributes, two different aspects, characteristics of an item, we construct something called a contingency table or cross tabulation, that as you see in front of you. So of course you can convert this data into percentages, 190 by, you can convert all of these into percentages. So 170 by 400 into 100 will give you a percentage, and so on and so forth. So if you look at this same table, instead of making absolute numbers, we are presenting now in terms of percentages. So what will the impression you get? Out of invoices collected, 83.75% invoices had no errors. Only 16.25% invoices had errors. That's one way of looking at it. Out of those invoices collected, majority of invoices were of small amount, that is 47.50%, and 35% had small amount, medium amounts mentioned in them. Only 17.5% invoices had large amounts mentioned in them. Things like that. So these are all examples of summary. Now that was for categorical data. Now we look into numerical data. So numerical data can be arranged into ordered arrays, which is basically listing the numbers in a ascending or descending order. We can construct frequency distributions using numerical data, or we can also construct something called cumulative distribution. Look at these examples one by one. So suppose you are surveying the age of college-going students, and you have two categories of students: those who are day scholars or those who are hostelers, or also called night students. So you're simply listing asking students about their age and listing those numbers in an ascending order. So 16, 17, 17, 18, 18, 18, and all that for day students. And for night students, the numbers are 18, 18 till 45. So what is the idea behind this? Idea is this: if you arrange your data into ascending or descending order, it is very easy for you to find the largest and the smallest numbers. That gives you an idea. For example, among the day scholars, the youngest was 16 years old and the oldest was 42 years old. Among the nights students or the hostelers, the youngest was 18 years old and the oldest was 45 years old. So you can see on an average, students, those who lived in hostels or night students, they were older of age, because probably they are working individuals who can only get time for evening schools or night schools, something like that. So that kind of inferences can be drawn by data arranged in a particular order. We can also construct something called frequency distribution. We're not going to the theory. We look at an example and then see what frequency distribution actually means. So remember, frequency distribution table is constructed for continuous numerical data. For example, we have got a manufacturer of insulation, electric insulations, basically those which go into heating devices, for example, room heaters. And he selects 20 winter days randomly to find out what is the daily high temperature. This is of crucial importance to that manufacturer, because room heaters are sold based on the temperature. The lower the temperature you get, and you will have higher the sales. So he's interested in looking at the high temperatures daily for 20 days, suppose that. So this is the data that he has collected. The step number one is to arrange this data into an ordered array. Let's say ascending or descending. So we have arranged this for the same data arranged now in an ascending order. That's step number one, always. Step number two is to find a range. Range is simply defined as the largest minus the smallest value. So highest temperature has been 58. This is in Fahrenheit. And the smallest temperature has to be 12. So 58 minus 12 becomes 46. So the range of data is 46. Now we decide that into how many different categories do we want to divide this data set into. There is no standard rule for deciding upon the number of categories, but there are certain conventions that we follow. Number one, the number of categories has to be odd, because odd categories give you a center. And conventionally, again, usually the number of categories is taken in between 5 to 15. More than 15 is too much, less than 15 is too little. So you decide upon the number of categories or class intervals, which we call them technically, to divide your data set into. So we decide, let's take an example, to divide the data set into 5 equal size class intervals or categories. So how do you decide the size of a particular class interval? So for that, we divide the range by the number of class intervals that we have chosen. Range is 46, number of class intervals that we have chosen is 5. So 46 by 5 gives you 9 point something, which is rounded off to the next highest integer, in this case, 10. Then we decide upon the limits of the class intervals. So we begin from 10, 10 to 20, a class interval of 10, 20 to 30, a class interval of 10, 30 to 40, 40 to 50, 50 to 60. You can also calculate midpoints. Midpoints are calculated like, for example, for the first class interval of 10 to 20, the midpoint is 20 plus 10 divided by 2, 15. For the last class interval, 50 to 60, the midpoint is calculated as 60 plus 50 divided by 2, 55, this way. So once you have decided upon the class intervals, the next thing is to count the number of values that lie between each of these class intervals. So the data is arranged in ascending order on the top, and in the bottom in the table, we have simply counted and put those numbers in the categories. So for example, in the above data, how many days did we observe temperature between 10 to 20 degrees? So we now count 12, 13, 17. There are only three values which there are 3 days on which the temperature was between 10 to 20 degrees. So we construct a column called frequency and write 3 against 10 to 20 category. Now look at 20 to 30 category. Now there is a question. 10 to 20 also has 20. 20 to 30 also has 20. So where do we count 20 actually? So the number is always counted on the lower limit side. So 10 to 20, the upper limit is 20. 20 will not be counted in that category. 20 to 30, 20 will be counted in that category, the next category, where it becomes a lower boundary. So now look at the data raw and see on how many days was the temperature between 20 to 30. So 21, 24, 24, 26, 27, 27. We only look at that. So there were 6 days in which the temperature was between 20 and 30. The frequency, we write 6 against 20 and 30, so on and so forth. For the last category, let's say 50 to 60, on how many days was the temperature between 50 to 60? 53 and 58. There were only 2 days where the temperature was between 50 and 60. All right, so this is how we construct a frequency distribution table. So this can also be converted into percentages, of course. So how do you construct percentages? Percentages are constructed by dividing the frequency by total frequency and then multiplying it by 100. So that gives you the percentage of frequency distribution table. So this is a frequency distribution table expressed in terms of percentages, right? We can also calculate something called cumulative frequency, and this is where we will stop today. Cumulative frequency is basically adding up the frequency as we go down the class intervals. So 10 to 20 has a frequency of 3. So cumulative frequency will be the same for the first class interval. 20 to 30 has a frequency of 6. So what do? We add 6 to 3. That becomes 9. That becomes a cumulative frequency. 30 to 40 has a frequency of 5. So what we do? We again add 5 to the last number that we had, 9. So it becomes 14, so on and so forth till we get 20. So this cumulative frequency can also be converted into percentages. What is the use of cumulative frequency? Cumulative frequency can give you quick answer to questions like this, that on how many days was the temperature less than 50 degree? So 18, cumulative frequency is 18. So 90% of days temperature was less than 50 degree Celsius. So we'll stop over here. Thank you for joining me today.